Welcome to homework.
We're asked to construct a finite state machine for entering a security code into an ATM. We're told the rules for the ATM is that the user enters a string of 4 digits, 1 digit at a time, that if the user enters the correct 4 digits of the password, the ATM displays a welcome screen, and that when the user enters an incorrect number or an incorrect string of 4 digits, then the ATM displays a screen that tells the user that an incorrect password was entered. And finally, if a user enters the incorrect password 3 times, we're told that the account is going to be locked. So, consider the inputs. Let's call the correct 4-digit password ABCD. And let WA, WB, WC, and WD represent digits other than A, B, C, or D, respectively. And finally, let W represent any digit being entered. So we have a few different inputs here. Now, let's consider 22 states, S0, S1, S2, all the way up to S21. And we'll see why there's so many of these in just a second. Of course, S0 is going to represent the fact, well, it's the start state. Now, we have that S4 is going to represent the correct code has been entered. So I'm sort of skipping around here, sort of show the important states here. And S21, the very last state, is going to represent that the account is locked. Now, the first attempt, so 4 digits, is going to use states S0, S1, S2, S3, and then S5, S6, S7. Where S5, S6, and S7 are going to represent that a wrong digit was entered in the code. So again, we're going to start from S0. Now suppose that a wrong digit is entered. At S0. Then we're going to move to S5. Now suppose that instead a correct digit is entered at S0. Then we're going to move to S1. Now, suppose we are at a state where a wrong digit was previously entered. Then we move right to the next wrong state. Until we've entered 4 digits. Then we move on to state S8. Where state S8 is the first state of the second attempt. Suppose that we are at a state where only correct digits were previously entered. Then we're going to move right to the next correct state. If we enter the next correct code. Suppose that we don't enter the next correct code. Then move to the wrong state to the bottom right of the state. And this is just for the first attempt, so likewise for these 2 other attempts. So we saw that the first attempt required 7 states, and we have that the other 2 attempts are also going to require 7 states, so that's 21 states right there. And we need another state for when it's locked, so that'd be 22 states. That explains why we need the 22 states. Now suppose that a wrong code is entered 3 times. Then move to state 21